We are done with Unit 7, sort of. And if you're watching this in a couple of years from now, or if I haven't changed this in a couple of years from now, you're going to wonder why I'm going to have this conversation. But holy crap, this last week sucked. 2 days we had off for like the windstorm of 2017, and then 2 days of like 24 inches of snow. So, yeah, I feel like I haven't seen you guys in a while, but I still got my coffee and I'm so happy. Marta, am I talking loud enough? Oh yeah, Marta, I'm talking to you. I'm really talking very loudly in the microphone just for you, Marta. Marta's one of our very nice foreign exchange students from España, from Spain. I think I said that right because I'm like bilingual. Not. Anyway, let's get started, kids. What do we got here? We got Unit 8. This is the in-class notes. If I mess something up, let me know about it, please. Just be nice to say, Mr. Krause, you seem to have made a mistake, sir, and I don't know why you make such common mistakes when you're doing things. That's my great British accent. All right, we've done these a million gazillion times. By now, this should be old hat. Some old horse caught another horse taking oats away. And then these are the co- or reciprocal, I probably spelled that right, functions. H over O, H over A, and A over O. Oh! Ah! Ayo! Don't even make fun of me. Dude, you do not want to make fun of my glasses are dirty? Oh my goodness, they're gross. Anyway, let's get going. The unit circle. You should know that this is 0 degrees or 360 degrees. You should know that this coordinates of this point is 1, 0. That should come as no surprise to you. This is 90 degrees. For those of you thinking radians, it's pi over 2. You should know that the coordinates of this point is 0, 1. This is 180 degrees, otherwise known as the infamous pi radians. And this is -1, 0. And finally, down here, we have 270 degrees, or 3 pi over 2 radians. And this point is 0, -1. Remember, the x value is the cosine. So the cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is -1. The cosine of 270 is 0. And the cosine of 360. The sine is the y value. The sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is 0 again. We've done these reference triangles before. You've seen these, right? Remember, we're going to make the hypotenuses 2 in both of these. Now, clearly, this is my smaller 30-degree angle. This is my larger 60-degree angle. Over here, it doesn't matter. They're both 45 degrees, so I'm only going to put in 1. So if you remember, opposite the 2, opposite the 30-degree angles, we're going to put the small side, which is 1. Opposite the 60, we put the square root of 3. So if you want to resort back to the triangles and not use the hand trick, that's cool too. On these, I just get the square root of 2 and the square root of 2. So you can either decide to use your triangles or your fingers. No, not that finger. No. What? An ace? That was not nice. Just kidding. All right, here we go. So, what do we got here? Let me look at the right diagram. So, the right diagram says we're going to do the tangent of pi over 4 minus the sine of pi over 6. Now, should you happen to use your calculator at this time, you type this into your calculator, you get a nice decimal, you will not be giving me the exact value. Before I answer that, I'm going to drink some Dunkin' Donuts coffee. Before I lecture students, I like to drink Dunkin' Donuts coffee. It makes my lectures less harsh and more friendly to my students. No, it doesn't. You use a calculator and give me some stupid decimal. You and I are going to be fighting. I'm going to win, and you're going to get kicked out of class. No, I won't kick you out of class. I might kick you, though, by accident. It'll definitely be by accident, though. So how do I convert? So if you don't like pi over 4, you can just convert to radian, from radians to degrees. Remember, that's multiplying by 180 over pi. The pi's cancel, and I get 45 degrees. Okay, so this is the tangent of 45 degrees minus pi over 6. Okay, let's convert from pi over 6 times 180 over pi. The pi's cancel, and I end up with 30 degrees. Now, this is now the sine of 30 degrees. Now, before I continue on there, I'm just going to give you a little heads up. If the denominator is a 3, the reference angle is going to be 60 degrees. Because 180 divided by 3 is 60. So it will just be a multiple of 60. If the denominator is a 6, the reference angle is going to be 30 degrees. Because 180 divided by 6 is 30, and any multiple, it'll be just a multiple of 6, or excuse me, a multiple of 30. And finally, if the denominator is 4, the reference angle will be 45, because 180 divided by 4 is 45, so it'll be a multiple of 4. So if I gave you something like 729 pi over 6, I know the reference angle is going to be 30 degrees. I have no idea what this is. I don't even care. It's going to have a reference angle of 30 degrees. It just is. Well, yeah, it just is. All right, let's move. So sine of 40, tangent of 45. So I can either come back up here to my reference triangle and use 45 degrees where opposite over adjacent and realize, oh, that's just 1. Or I can use the finger trick, right, where I say, okay, sine of tangent of 45, the middle finger, is that right for you? It's going to be, this is x and this is y, so it's square root of 2 over the square root of 2, which is just 1, minus the sine of 30. Well, I can either use my reference triangle, sine of 30. Remember, sine is opposite over hypotenuse, so I come over here to my 30-degree angle, and this would be opposite, and this would be hypotenuse, so that would be 1/2. So this is 1/2. Or I can just use my fingers. 30 degrees is this finger. Remember, this is cosine, square root of 3 over 2. This is sine 1/2. So 1 minus 1/2 is 1/2. There is your answer. Now, if you were, in fact, to put this in your calculator, it would tell you that the answer is 1/2. But if you don't show me any work, you get no credit. All right, you know me. I got to pause every 5 or 6 minutes. I'll be back. Did you miss us? I said us, me and my cup of coffee. Dunkin' Donuts. It makes Algebra 2 Common Core so simple. Nailed it! Another great commercial. Oh my God. So, sine of 45. Let's go back up to our 45. Now, hopefully by now, at least the half of you probably already know what that's equal to. Right? Sine of 45, you already know what that's equal to. But for those that you don't, remember, it's opposite over hypotenuse, square root of 2 over 2. So 3 times the square root of 2 over 2. For those of you that have Miss Newman, you'll know she says, parentheses for trees. Make sure you sub in using parentheses. I don't say it that annoyingly. I just told you a few minutes ago, if it's divided by 6, it's got a reference angle of 30 degrees. Not only that, I think we already did pi over 6. So that's a reference angle of 30. So I need to do the tangent of 30. Now remember, tangent is opposite over adjacent. 1 over the square root of 3. So 1 over the square root of 3. This looks like it's going to be sort of a mess. So this first one is going to be 3 square roots of 2 over 2 minus 4 over the square root of 3. Now, the problem with this is we are not allowed to have a radical in the denominator. So I got to transpose this 4 radical 3 thing. So 4, I was trying to give you the answer without doing the work. So this is really 4 over the square root of 3. To rationalize this, what we have to do is multiply by the square root of 3 over 3. That's a really ugly pen. Where did that one come from? So that equals 4 square roots of 3 over 3. So this thing here really just becomes 3 square roots of 2 over 2 minus 4 4 square roots of 3 over 3. And you could probably just leave it like that. That's sort of annoying enough. There is a better answer with a common denominator of 6, but let's leave it like that. Oh my God, I love these questions because they look so complicated, but they're so easy. When I do an easy trig problem and I need more caffeine because I'm dying and I'm late at night and I'm not going to be swimming tonight, I drink coffee. All right. So I get this obnoxious thing right here. And I'm like, wow, that couldn't be any more obnoxious. And then I say to myself, wait a second. There's a major part of this problem I might have just missed if I hadn't read the carefully. It's a point on the unit circle. If I give you a point on the unit circle, this then is the cosine value, and this then is the sine value. So I already know sine of theta. Sine of theta is just equal to 4/5. Cosine of theta is equal to -3 over 5. Now, if you want tangent, there's a couple of ways of doing tangent. Tangent, if you recall, tangent theta is equal to sine theta over cosine theta. Or in other words, 4 over 5 divided by -3 over 5. Now, in order to get rid of this, we take this and we multiply by the reciprocal, 5 over -3. Notice the 5's cancel, and I end up with -4 over 3. Just leave negatives in the numerator. Now, if you didn't like that method, because that's one way to do it, and that is the right answer. If you didn't like that method, what you could have just done is said, oh, this is going to be in a right triangle. I know that sine is opposite over hypotenuse. I know that cosine is adjacent over hypotenuse. And I know that tangent is opposite over adjacent, 4 over -3. So tangent, in my big bold black pen here, is -4 over 3. Find the exact value. Guys, I want you to do me a favor. When you see this word exact value, I want you to highlight it. And then I want you to say to yourself, no Taschenrechner. I don't know how to spell that exactly. No calculator. None. None. Don't touch your calculator. You get hurt. So let's see what we got here. Find the exact value of the remaining trigonometric functions if this is true and this is true. Well, there's two parts to this problem. 1 and 2. Oh, I got to tell you what they are. 1, you got to figure out which quadrant you're in. And 2, you got to figure out where you're going to draw your triangle. Oh, then 3, find the other missing sides. Then 4, find the answers to the questions. Oh my God, this one's hard. No, it's not. Here's what I'm telling you. I'm telling you that tangent is positive. Now, right now, I'm going to figure out what quadrant it is. So tangent is positive, but sine is negative. That's what this says. That's the only thing that says is sine is negative. That's going to tell us what quadrant we're in. So all students take calculus. Tangent is positive here and here. Sine is negative here and here. Therefore, this is an angle that terminates in the third quadrant. So I don't know if I know Miss Newman does this, and I think this is sometimes a good deal. For those of you that are having troubles drawing your triangles, know that you have to pick one of these 4. 1, 2, 3, or 4. Now, in this case, we are going to use the angle or the triangle in the third quadrant. So I want to pick a triangle in the third quadrant. There's my triangle. Wait. Got rid of too much. All right. So what do I know? Now, there's my angle. So now I'm going to talk about this angle right here. There's my angle. I got it being in the third quadrant from this. So the only other piece of information that I was given is the fact that tangent is 12 over 5. Now, if you remember correctly, tangent is equal to opposite over adjacent. So if I go back to my diagram over here and I say, okay, tangent is opposite, 12, over adjacent, 5. We don't need this 2 anymore. So, okay, now I need to find the missing side. Well, the missing side, kids, is right here. And I could either do the Pythagorean Theorem, or you guys could just know that this is 13. This is a 5, 12, 13 triangle. Whether or not you did that or did 5 squared plus 12 squared equals x squared, and figure out what that is. Now, one last thing I got to figure out, and that is the fact that we're in the third quadrant. So really what I have here is -5 here and -5 here. Now, the negative in this case is directional distance. It's like a vector. We're going out -5 this direction and -5 12 that direction. All right, so now I'm ready. Sine, cosine, tangent. Now, tangent's easy. I already got it, right? 12 over 5. And since tangent's easy, so is cotangent, because I just got to flip it. 5 over 12. Now, cosine's a little trickier. Cosine is adjacent over hypotenuse. So that's -5 over 13. So that would mean, let's see, what's its reciprocal function? Oh yeah, secant. Remember, we don't like students, so we didn't pick our letters to match. So -13 over 5. And I don't like putting negatives in the denominator. I usually leave those in the numerator, that one. So sine then would be opposite over hypotenuse, opposite being the -12, hypotenuse being the 13, so -12 over 13. And its reciprocal function is cosecant theta, and that would be -13 over 12. And there's your answer. All right, be back in a minute. Oh yeah, you caught me. So again, find the quadrant we're working in. Oh, we're in quadrant 3. That one's pretty easy. I just draw a triangle in quadrant 3. Now again, if you struggle with this, draw in your bow tie and figure out, we're going to work in this quadrant over here. So this is the quadrant. I'm going to draw this one. So this is the quadrant we're going to work in. That was one crazy good-looking triangle right there. All right. Well, Mr. Krause, Miss Newman hate me. So I want the remaining ones. So sine, cosine of theta, cosine of theta, tangent of theta, cosecant theta, secant theta, and cotangent theta. Now, the reason we're not giving these to you, I thought about this the other day, the reason I'm not going to put these over here for you is because I want you to write them like this. I want you to understand that these two go together, that these two are reciprocal functions, and these last two are reciprocal functions. You should know that. All right, so I know secant is -5 over 3. Therefore, I know cosine is -3 over 5. Now, that's important, kids. I'm in the third quadrant. This is the only thing I care about. The fact that they gave me secant, I don't know anything about secant, but I do know a lot about cosine. Cosine is adjacent over hypotenuse. So I'm going to come back to my triangle, my little triangle over there. Triangle over there. It's past my bedtime. And I haven't gotten my phone yet, so hopefully I'll get that soon. And that is adjacent, -3, over hypotenuse, 5. Now, once again, chillin', hopefully you know this is a 3, 4, 5 right triangle. Now, let's deal with directional distances. We're not actual distances, directional distances. We're in the third quadrant, so this would be a -4. Once I got that, the problem is a joke. Sine would be -4 over 5. Cosecant would be -5 over 4. Tangent is adjacent over hypotenuse, 4 over 3. And cotangent is just the flip of that, 3 over 4. And notice these two are positive. And notice I didn't put -4 over -3. That would be not acceptable. Okay, two negatives make a positive. Clean it up, kids. Now, if you thought these problems were hard, this problem here is super duper 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 easy. Because all I'm asking you about which quadrant you're in. Now remember, the only thing I care about is positive or negative. So I'm going to bring up my axes. How do I show work for this? Everybody, how do I show work for this? All right, this says cosine is... Hold on, I got to take this. It's my neighbor. I have an old German neighbor who I was snowblowing her driveway, and I'm guaranteeing she's bringing me some goodies. Which means I just have to hit the treadmill about 10 times longer. Oh, that good German cooking. And I can't even taste it. Whatever. For those of you that don't know me, I can't smell things and I can't taste things. Which means I really can't taste this coffee, but in my brain I know it's delicious. Sorry, I had to take that little phone call. Anyway, let's go. Cosine is positive. Everything is positive in the first quadrant, but then I got to remember all students take calculus. All things are positive in the first quadrant, and cosine is positive down here. So that one gives me those 2 stars. Tangent is negative. All right, so where is tangent negative? Tangent is positive down here in the third quadrant and positive in the first quadrant, so it must be negative here. That's a great star. And here, who's the big winner? 4. You should really write it like this, look all professional. In unit quadrant 4. Right? Don't use this. This is like, I don't know what I'm talking about. Find the reference angle for negative 4 pi over negative 5. Can you tell my neighbors here? Well, my dog's upstairs going nuts. She's not too smart. Now, let me give you a little forewarning. You are not allowed to give me the answer to this in degrees. It must be given in radians. If I give it to you in radians, you give it to me in radians. If I give it to you in degrees, you give it to me in degrees. Now, you might want to convert it to radians and then convert it back, which is sort of a pain in the neck, but that's okay. For those of you that are a little bit smarter than the average person, I will teach you another way to do this. So remember, we're always looking to see how far away we are from 180 degrees and from 360 degrees. How far away are we from 180 and how far away are we from 360? Okay? So, first thing I'm going to do is convert this. So negative 4 pi over 5 times 180 over pi. Those pi's are going to cancel. Let's see. 5 goes into 180, I think 36 times 4. This is negative 144 degrees. Now this negative makes a huge difference. Because I'm going to start here, and I'm going to go back. Remember, it's negative 144 degrees. So then you got to say to yourself, how far am I from 180 degrees? So if I take 180 and I figure out, okay, what's the distance between these two angles? Oh, that's 36 degrees. So 36 degrees would give you partial credit, but it's not full credit. I need to convert that back to radians. So I'm going to take 36 degrees, and I'm going to, over 1, I'm going to convert it back to radians, and I multiply by pi over 180. So what I end up with is 36 pi over 180. Now don't leave it like that. That's sort of annoying. If you can't reduce that quickly in your head, which most of you can, you grab your calculator and you do 36 divided by 180. Hopefully this will give it to me. Doggone it. If you reduce that and I gave you to you in the other way, it would tell you it's 1/5. So this is pi over 5. Now, for those of you that are really smart, or you really just want a faster way to doing it, because that was about 10 times too much work, you can always do this. If you remember correctly, 180 degrees, because that's how far we want to figure out how far away we are from 180 degrees, is equal to pi. Well, another way to write pi is 1 pi over 1 pi, or 2 pi over 2 pi, or 3 pi, 1 pi over 1, 2 pi over 2, 3 pi over 3, 4 pi over 4, or 5 pi over 5. Now here's the important one. My question is, how far away is 5 pi over 5 and 4 pi over 5. Oh, well, aren't they just pi over 5 away from each other? Yeah, so there's your reference angle. So for those of you that got that, great. For those of you that didn't, convert it to degrees, change it back. It makes it a little bit more of a hard problem. But, let me give you another example because I'm not sure you understood that one. Now, you got to remember that your answer's got to be less than 180, less than 90 degrees. So let's say I gave you 9 pi over 7. Okay, I want to know the reference angle. Well, I can change this to 7 pi over 7 and say to yourself, well, how far away is 9 pi over 7 from 7 pi over 7? Oh, 2 pi over 7. There's your reference angle. That's what's nice about radians is it really makes it quite easy to do. All right, let's see what we got here. Hey, look, let me see what I got. I got to pause. I'll be right back. Okay, a local airline does not offer a direct flight from Detroit to Washington. Rather, the flight must travel from Detroit to Buffalo. Use the diagram to know the distance between. So, what? Here's Detroit. Here's Detroit. There's Rochester. And there is Baltimore. So I got to go from Detroit to Baltimore, and then from Baltimore to Rochester. Use the diagram below to find the distance between Detroit and Rochester to the nearest mile. Well, this is just a right triangle. Really? So all I really got to do with this right triangle is just do the Pythagorean theorem. Don't forget the hypotenuse is always on the right side of the equation. So I'm going to do x squared plus 256 squared is equal to 325 squared. Or x squared plus, this one I don't know off the top of my head. What was it? 256 squared. 536 is equal to 325 squared, which is equal to 105,625. 105,625. Subtract those. And I get 4089 is equal to x squared, or x is equal to you guys may not like this. I'm just going to take the square root of it, which is really just to the 1/2 power, and I get 200.22. 200.22. So x rounded to the nearest mile, x equals 200. That's it, kids. Pythagorean theorem. Couldn't get any easier than that. Convert 3 pi over 4 to degrees and express the answer in simplest form. Oh, so all we got to do is take 3 pi over 4 and multiply it by 180 over pi. The pi's cancel. And 4 goes into 180, 45 times. 3 times 45 is 135. What they didn't want on this one was 3 times, they didn't want 540 over 4, right? Because you could have just multiplied the numerators 3 times 180 and got 540, and then all over 4. They don't want that. They want it reduced, so 135 degrees. Convert negative 5 pi over 2 into degrees. So negative 5 pi over 2 times 180 over pi. The pi's cancel. 2 goes into 180 90 times. So I get negative 450 degrees. So if I convert from degrees to radians, or from radians to degrees, this is what I multiply by. If I convert from radians, so we're still doing that same thing, but notice how I'm representing radians here, and notice how I'm representing radians here. I'm going to convert 3.2 radians to degrees. So I'm going to multiply by 1.180 over pi. Now, if you remember correctly, 180 degrees is equal to pi, which is equal to 3.14 radians. Correct? This is 3.2. So whatever my answer is, it better be bigger than 180 degrees. Probably somewhere around 190 degrees would be my guess. So I come over to my calculator and I go 3.2 times pi divided by 180. And I get, oh, well, I'm glad I did that. I actually put that in there backwards. I multiplied by pi over 180. But the problem with it is, notice what I come up with. If you end up with this as an answer you're going to give me for how many degrees there are, and you say, oh, round it to the... Oh, her answer key doesn't make any sense on this. Round to the nearest minute. We didn't discuss that this year. So let's just round it to the nearest tenth of a degree. So if you give me this answer, say, oh, the answer is 0.1 of a degree. No. That means you put this in backwards. 3.2 times 180 divided by pi. And there it is, 183.3 degrees. 183.3 degrees. Now, one of the things Miss Newman had on here is her answer was, no, her answer's wrong. So 180, whatever I just said, 183.3 degrees. That's right. All right, convert 135 degrees to radians. So we want it as the simplest as a multiple of pi, which means I don't want a decimal answer. So instead of multiplying by 180 over pi, we're going to multiply by pi over 180. Well, this is just 135 pi over 180, except I want it in, well, it should say in simplest form. It doesn't. But the easiest way to do that is, and if I got to switch this, hold on a second. Settings, document settings, exact. Okay. So if I do this 135 divided by 180, it should give me 3/4. So this is really equal to 3 pi over 4. Now this one I shouldn't need my calculator for. 18 degrees times pi over 180 is equal to 18 pi over 180. I'm assuming you all know that 18 goes into 180 10 times. So this is really just pi over 10. Alrighty, so we're going to convert 251 degrees to radians and express your answer rounded to the nearest hundred. So we're going to do that same thing. 251 degrees, we're going to multiply by pi over 180. And they said round to the nearest hundred, so that just means grab your calculator. Now remember, 180 degrees is 3 radians. This is 251, so no matter what I come up with, it better be bigger than 3.14, which is pi. So let's see, let's go to our calculator. 251 times control division pi over 180. Oh, and I got it as exact. Oh, man. Wait, hold on. I think I can hit Control Enter. There it is. Control Enter. 4.38. Round to the nearest hundred. So 4.38. Stop. 4.38. Write the equation of the cosine function whose maximum is 200, whose minimum is 140, and whose period is 10 hours. So let's talk about amplitude. Now you remember we have a formula for amplitude. It's absolute value of max minus min over 2, because that will give you the average, which is going to give you the middle value of this, correct? So this is equal to absolute value of 200 minus 140 over 2, which is equal to absolute value of 60 over 2. So my amplitude is 30. So now A is 30. answer key's wrong on this one too, but that's okay. I'll have to fix it for her. So let's talk about period. You remember, period is equal to 2 pi over b. Oh, let's see what we got so far. Our equation is y equals a times, what's this, cosine or sine? Cosine bx plus c. Correct? All right. So I'm going to find, I got a. I'm going to find a. So I got a. This is equal to, let's do it. Move this up a little bit for you. I know what a is. So this is y equals 30 cosine. Now I'm going to try to find b. Well, they told us that the period was 10 hours. So I'm going to say 10 is equal to 2 pi over b. Now notice I'm looking for b now, so I'm going to cross multiply. So I get 10b equals 2 pi, or b is equal to 2 pi over 10, which is really just pi over 5. So now I know b is pi over 5. So now I'm at this one, pi over 5x. Now I just need a midline. Well, let's think about this. If I was looking at my axes and my maximum was 200 and my minimum was 140, and we know that midline runs right in the middle, or down 30 or up 30, that will tell us what this is, and that will be our midline of 170, so plus 170. So that was kind of a tricky question, but there's the answer right there. Regardless of what Mrs. Newman's answer key says, that actually is, in fact, the right answer. She and I need to have a little conversation. Nah, guys, I'm telling you, man, you do this stuff for a living. By the time you've done it a million times, you're like, oh, you just make dumb mistakes. All right, so we're going to write the equation of this curve. So the first thing I want to do is try to figure out if I'm going to be writing a cosine curve or a sine curve. Now, remember, a cosine curve is going to start at a max, end at a max. A sine curve is going to start at 0, end at 0. So we're looking for that starting point. Is it starting at a 0 or is it starting at a max? Now, a cosine curve could also start at a min if it's got a reflection. So let's see what we got here. The first thing we're going to do is draw in our midline, right down the middle. So did we start here at a 0 or did we start here at a minimum? And I think it's clear that we started at a minimum, so this makes it a cosine curve. So a cosine bx plus c. Well, I just drew in the midline, so I should know what the midline is. It looks like our midline's right here at 2. So I know we're at plus 2 for this. The a is pretty easy. I'm going to go up 1 or down 1. So my a is 1. However, I'm starting at a minimum, so I got to start at a negative 1 or just negative cosine. Now, remember, this b value, sometimes this is tricky. Remember, this is our frequency. How many full cosines in 2 pi? So I got to find 2 pi. That's right here. So let's see how many full cosine curves. 1, 2, 3. So I did 3 cosine curves. So there it is, kids. There's the answer to this question. Hey, Mrs. Newman, I agree. I'll be. All right, children, here we go. We're going to graph this. How many solutions exist over the blah, 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 blah of this? So really what we got to do is graph this. I'll show you what that negative 1 means in a minute. We're going to graph this. So how am I going to graph that? Well, that's a cosine curve that's going to start at a minimum. Now, I'm not happy about this I have to go over to 0 pi. So, all right, so let me do this. A is 1.5. B is 2, which makes my period equal to 2 pi over 2, which makes this just pi. And that means that so then my scale, my x scale is going to be pi over 4. But if I look at what I got here, let me try to blow this up. If I look at what I got here, I've already given you the scale, so I've sort of messed you up a little bit because I've already given you the scale. But we need a scale of pi over 4 because we decided our scale was going to be pi over 4. So in order to really graph this thing, I need to create a scale of pi over 4, which means I need to count by pi over 4s. 1 pi over 4, 2 pi over 4. So this is pi over 4. This is going to be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So this is really 8 pi over 4, which is 2 pi. Now the reason I did that was because I want to graph this thing accurately. So it's going to start at a min because it's negative 1.5, right? So it's because it's negative, I'm going to start at a min, negative 1.5. Now I'm going to end at a min. Now be careful. Where am I ending? Oh, I'm ending here. Because my period is pi. In between those, I'm going to go to a max. That's up 1.5. In between those, I'm going to go to zeros. Now, since it wants me to do this over 2 pi, I got to do this again. So, terrible drawing, but not bad. Then it says, how many times does it equal negative 1? It didn't ask for what the x values are. It just says, how many times does it equal negative 1? Well, let me draw in negative 1. There's the line y equals negative 1. Well, how many times does it hit? Once, twice, 3 times, 4 times. The answer is just 4. There are 4 points of intersection. Now, I hope you understand that because I needed this scale of pi over 4, I really just had to adjust that scale. So that was a little bit tricky there. So let me unblow this up. So if g of x is equal to that, what is the minimum value? Now, if you remember correctly, remember min and max are c minus a and c plus a. Don't get all worried about this. This is just a shift to the right or the left. In this case, it's to the right, pi. So, let's see what we got here. My a is 4. Not negative 4. My a is 4. My c is 1.5. So, my minimum is going to be c, which is 1.5, minus 4. So, my minimum is going to be negative 2.5. There's my minimum. Don't worry about this. This is old curriculum. Uh-oh, SpaghettiOs. Proofs, or just simplification. So what we're going to do, don't forget, my goal on these is to see, can I transform everything into either a sine or a cosine? Now, you better have these things memorized by next week, okay? Cosecant is 1 over sine of a times, now this is already a, so sine squared a. Make sure you read that like a boss, okay? Not like a chump. This sine a cancels with one of these, and it leaves me sine a. That's it, kids. That's all she wrote. So over what interval is cosine x is the inverse also a function? So this was something we kind of really glanced over because of the 18 snow days. So let me draw in the normal cosine curve. Pi over 2, pi, 3 pi over 2, and 2 pi. So if I drew in the cosine curve, the normal one, starts at a max, ends at a max, it's got a minimum in between, zeros in there, 0 there. And if I draw it in, and I say to myself, Where can I restrict this thing to so that it will pass the horizontal line test? Because notice, if I do this, oh, I've passed the horizontal line test. I'm so happy I passed the horizontal line. Don't stop! You're going to fail. Don't go past here. Stop! Right? Because if I hit this, if I keep going, I'll fail the horizontal line test. Same thing here. Ooh, yeah. Oh, stop! So what I want to do is I want to stop it here, right? Because if I just look at this piece right here, right? If I just look at this piece from here to here, then no matter where I draw in a line, I only hit it once. So from 0 to pi. All right, I got to start marking her wrong answers. I'll go back to them because that was another one that was crazy. All right, we're almost done, kids. Almost done. Oh, I better stop. Only a few more problems. Let's see. 1, 2, 3, 4 more problems. Oh my God, I'm so excited. Oh, look at this one. This one looks rough. Kind of scary. All right. So remember, find the midline first. Midline first. Always, always, always. So I'm going to find the midline. This is 8 for my max. And my minimum is 2. Halfway between those two would be, I believe, 5. Up 3, down 3. Does that look like the middle? Now the next thing, as soon as I find my midline, I want to determine whether or not this is going to be a cosine curve or a sine curve. Now since it doesn't start at this spot right there and end at this spot right there, it must be a cosine curve. So I know this is going to be a cosine curve. So I'm going to write this in there, generic in there. Y equals a cosine bx plus c. Now I've already found the midline, so I'm going to toss that in. That's plus 5. It's right here, this 5. I can now find the amplitude, which is 3. So I know it's 3 cosine x, except that it's not starting at a maximum and ending at a maximum. It's starting at a minimum and ending at a minimum, so I need a negative out front. Don't forget to look for that. So I got the hardest part left. And finding b and the idea of period and frequency is always going to be kind of the tricky part. Remember that period is equal to 2 pi over b. And don't forget, b is what I want to go in there. That's my frequency. That's what goes in there. So I need to figure out b. Well, remember, period is defined as the length of time or length it takes to finish one full cycle or one full curve. Well, how long? This is one full curve right here. Starts at a min, ends at a min. This is one full curve. Well, what's it taking to finish it? It's taking 30 to finish it. Now I know that looks weird, but that means my period is equal to 30. And I know that period is equal to 2 pi over b. And I just cross multiply. When I cross multiply, I get 30b equals 2 pi. Now I want to get b by itself, so I'll divide by 30, and I get pi over 15. So now I know this last little piece is pi over 15. And that, my friends, is the answer to this question. Yay, we both agree on this one. Okay, starting with sine a squared plus cosine a squared equals 1, derive this formula. All right, so I need to somehow come up with tangent, and I need to somehow come up with 1. Now, that's the easiest way to do that is just to divide by cosine squared a. Divide by cosine squared a. Divide by cosine squared a. Well, if I divide this by cosine squared a, I end up with tangent squared a plus cosine squared a divided by cosine squared a is uno. And 1 over cosine squared is secant squared A, which is what we wanted. There we go. That's all she wrote, sisters. All right, verify the identity. Remember, you can only mess with one side. Always mess with the more complicated of the two sides. So I'm just going to distribute this. So this becomes secant squared x minus secant x cosine x, and we want that to end up being hopefully tangent squared x. Well, let's see. I'm not really sure what this is. Let's leave this as secant squared for now. Minus 1 over cosine x times cosine x over 1. Oh, well, these cancel, and that leaves 1. So this is just secant squared x minus 1 equals, we still want this to equal tangent squared x. Now, I'm not allowed to mess with the right side, so I have to do something over here. And you can't do anything with 1, but I certainly can do something with this thing. Let's see, what is secant squared equal to? Oh, wait a second. Secant squared, I wonder why we did this here, is equal to tangent squared plus 1. So I'm going to replace this with tangent squared plus 1 minus 1 equals tangent squared. Well, what happens to these ones? They cancel, and I end up with tangent squared x equals tangent squared x. All right, boys and girls, last problem. Graphing the tangent curve. Now, if you remember correctly, tangent is undefined when cosine is equal to 0. So tangent is undefined because it's sine over cosine. It's always undefined when cosine equals 0. Well, if you don't remember when cosine equals 0, start trying values. But if you remember correctly, cosine is equal to 0 at pi over 2, at 90 degrees, and at 270 degrees. It's also at negative pi over 2 and 3 pi over 2. Now I need to graph this. Ooh, wow, that's terrible. So I'm going to graph this way. I'm going to graph it with this big dot here. So remember, it's going to go to the origin, and it's going to approach this line asymptotically. Approach this line asymptotically. But it's a repeating function. It's going to start here, and it's going to do that same thing this way. I got to start here. Now, I can't go to the right because I only want to go between 0 and 2 pi, so I can only go this way. And then I'll start here and go again here and down here. Start here and go up that way. And there is tangent of x over the interval from negative 2 pi to 2 pi. And I believe we're done. Yay! Okay, we still got the homework assignment. Don't forget about it. Keep working hard, kids. You can do it. You can handle this. All right? Catch you on the flip side.